So good morning again, everyone. Today we will be doing lecture 4, the respiratory system. It's quite an easy system after we, survive the blood and the immune system. The respiratory system will be relatively easy. Okay, so I don't think we're gonna need the entire, a lot of time. We'll see how it goes. And when more people get here, we will talk about what you have to do next week, because there is the lab coming up. There is, tutorial on Monday, and then there is the lab quiz as well as the actual tests. Okay, so more information to come. But first, let's get started with the study guide. Okay, so in the first question here, it says, list all the structures that the air passes through to go from the air to the site of gas exchange. Okay, circle all the structures that are part of the upper respiratory system in red, and circle all the structures that are part of the lower respiratory tract in blue. Okay, so we start with the nasal cavity. Right? We breathe in through our nostrils, and then the air goes to the nasal cavity. From there, it is going to enter the pharynx. Okay, and we will talk about the structures in the next section here. From the pharynx, it will go through an opening called the glottis. Okay, of course, covering the glottis is a cartilage flap called the epiglottis, and prevents the food from going into your airway. After the glottis, the air will go into the larynx. Okay, so another word for larynx is your voice box. And I should mention another word for pharynx is basically your throat. From the larynx, the air is gonna go into the trachea. Okay, so trachea goes from here, right? And all the way down, maybe about 15 centimeter, 12 centimeter to 15 centimeter, depending on how tall you are. And then it's gonna split into the bronchi, okay? So the left and right main or primary bronchi. You have the right bronchus and you have the left bronchus. So B-R-O-N, bronchi, okay? So I is plural, US is singular. Okay, so you have the primary bronchi, which would further branch into the secondary bronchi and then tertiary bronchi. Okay, so only the primary bronchi is outside of the lungs. As soon as they enter the lungs, they will split into these secondary and tertiary bronchi, forming the bronchial tree. Okay, it's kind of like an upside down tree, right? At school, we have a model of a cat lung, and you can see very, very beautifully that it forms exactly like an upside down tree. And as the branching continues, the bronchi will eventually become bronchioles. Okay, these are smaller airways, even smaller than the bronchi. And at the end of the bronchioles, we would have the LVO line. Okay, I just got a message on my screen saying my internet is unstable. If I'm being choppy, if I'm getting cut off or something, just let me know, okay? Sometimes it happens. And then I might have to physically move to another location. Okay, next. Briefly describe the anatomy and functions for each of the following structures. Okay, so, sorry, I forgot to circle the stuff that is the upper respiratory tract. Okay, so for upper respiratory tract, we want to circle them in red. Okay, so anybody know what's the boundary between the upper respiratory tract and the lower respiratory tract? Okay, where do we draw the line? Anyone? Not yet? Okay, so
the upper be the nasal cavity.
Yeah, the nasal cavity is upper, yeah, and then all the way to where? Do you know?
Trachea.
Right before the trachea. That's right. Okay, so like the nasal cavity, pharynx, glottis, and larynx, all these are part of the upper respiratory tract. Okay, and then starting at the trachea all the way in, that's going to be your lower respiratory tract. Okay, so if you have an upper respiratory tract infection, it means the infection is occurring, you know, in these locations. Like if you have a strep throat or something, right? That's basically infection of the pharynx, right? If you have a cold, that usually is upper respiratory tract infection. Those goes away relatively quickly. If you have a lower respiratory tract infection, like pneumonia, right? Bronchitis, okay, bronchiolitis, right? All those things are going to, you know, it's gonna feel miserable. You're gonna feel miserable, and also it's going to linger a lot longer. Okay, just because, you know, it's further down and there's more space to spread. It's warmer down there, and you know the damage is more extensive typically compared to the upper respiratory tract infection. Okay, so that is that. Now, moving on. Okay, just give me a second. I think someone is trying to join the link and it's not working. So I'm gonna help him out. Just give me a second, okay? Let me pause the recording. So let's take a look at each of the structures a little bit closer. And again, right, this is under the assumption that you have watched the recordings. I know some of you said in the survey that you didn't have time to watch it, and you know you prefer everything to be live. But I think the recording works better for a majority of the people because a lot of you, I assume you have to go to work, you have other obligations, you have to watch your kids. So, you know, rather than, you know, locking you in for 3 hours live, watching the recording is probably a better choice. So nasal cavity, anatomy and function. What is the function of the nasal cavity? Well, nasal cavity it's actually quite big, right? It's not just the nose. It actually opens up all the way inside. I'll show you a diagram of that later. But the function of the nasal cavity is basically to warm the air that we breathe. So warm, filter, and moisten the air. Okay, that's the main function of the nasal cavity. Okay, and it opens up to sinuses. Okay, so sinus. I'm not sure what the plural of sinus is. I'm just gonna say 4 pairs of sinus. Okay. So you have your frontal sinus, right? You have your ethmoid sinus. You don't have to know the names yet, but sinus is basically cavities within bones. So they're named after the bones they are found in. So this is called the frontal bone, and you know the 2 sinuses here. That is the frontal sinus. Okay, so that is the nasal cavity. All right. So let's take a look at this diagram. It's something that I already labeled in the lecture, but let's go through it quickly. Okay, just, you know, for those of you who need a refresher. This is a sagittal view of the head. Sagittal, like you cut this way, right? Okay, and you're looking at it from the side, and you can see this here, this entire area is the nasal cavity, right? So it's really big, right? Nasal cavity. Okay, like, I mean, if you pick your nose, you can only feel like this area, right? Okay, and then when you do the COVID swab test, they actually have to stick the thing all the way in, right, to collect some samples, right? That's why it's kind of uncomfortable. I haven't get it done myself, but you know, my family has, and they told me, you know, it's not a pleasant experience. Okay, so that's the nasal cavity, and you can see it opens up to these sinuses that we're talking about, right? The frontal sinus, right? Sphenoid sinus at the back here, and then there are 2 other ones that you cannot really see because it's kind of like, you know, over here in this area. Like do you remember, like when you go to the doctor, sometimes they would like press on these places, right, on your face and ask if it hurts or not, right? They are basically feeling the sinus, right? Pressure points, as well as they will feel your lymph nodes, right? Because those are the places that are gonna be swollen if you have some kind of infection. Okay, so that's the nasal cavity. All right. Now, what goes through the nasal cavity? Well, air goes through the nasal cavity. Okay, so air is going to come in through the nasal cavity, and then it's going to go to the pharynx, the throat, and then down, down your airway like this. So that's for air. Now, there's another path here, and that is for food. Okay, so food and water, food and liquid. Okay, that is going to go through your mouth, right? And then it's going to also pass through the throat, and then it's going to go down this tube. Okay, so separating the nasal cavity and the oral cavity, just fancy word for your mouth, are two bones, right? So if you take your tongue and then you push up, right, you will feel there's something hard on top. That is your hard palate. Okay, so you can see in this diagram, this area here, this bone, right? That's the hard palate. Hard palate. It separates the nasal cavity from the oral cavity, and the hard palate is actually made up of two bones. Okay, the anterior 2/3 is a bone called maxilla. And you don't have to know this yet. You will learn it again later on, okay, in the course. But I write it down in case you want to, just jot it down, kind of, plant the seed for now, and then it will come back later. So maxilla is also the bone that forms your upper lips here, okay, and it forms the socket for the upper row of your teeth to sink in. Okay, so that is the maxilla, and then behind there's another bone called the palatine. Okay, so these two bones forms the hard palate. Okay, now depends how flexible your tongue is. If you curl back, right, keep on feeling the roof of your mouth, eventually it will become soft, right? Okay, and if you open your mouth and in front of a mirror and say and look inside, you will see there's something dangling at the back of your throat, right? Okay, like it looks like if you look at it from in the mirror, it looks something like this. You guys know what I'm talking about, right? Like, this would be a tongue, and you say and then there is that thing, right? Okay, so that thing, the little dangling thing, that's the uvula. That is the extension of your soft palate. Okay, so the soft portion is the soft palate, and then it ends with the uvula. U-V-U-L-A, uvula. Okay, so what's going on here? Well, if it's the air that's going in, then it's going to go into the pharynx, the throat, through an opening here. Okay, so that's what E is pointing at, right? The opening. That opening is called the nasal pharynx. Okay, you essentially entering the pharynx through the nasal cavity, right? Okay, and then here, if you're eating food and liquid, you're gonna enter the pharynx through the opening here. Okay, so that is the oral pharynx. You're entering your pharynx through the oral cavity. And over here, there's another opening here for the air to go into your larynx, as I said. So this is the laryngeal. Sorry, can't spell for the moment. Laryngeal pharynx. Okay, so that's where the air will leave the pharynx and then into the airway. Okay, so any question about, what's going on here with all the openings and the connections? No questions? Okay, so for a more detailed explanation, go for the recording. Yes, Ruby, go ahead.
I have no question, but I just want to know what's the technique to remember all these things so easily.
Oh, I mean, it's it's very cliche. It sounds like I just keep on, saying all these words without much effort, but that's because I teach it for like over 12 years now, right? This is my 12th year at Centennial. So like I've been just repeating it. So for many students, I would suggest to maybe print off a blank sheet and just label it, okay? And when you label it, you try to write out as much information as you could possibly. And if you do that like on a regular basis, it's going to help, right? Like, I don't know if I mentioned this to class, but in biology or in anatomy, it's no use to read the notes. It's no use to read the textbook, right? It's useful to read it, but then like that alone is not going to help you remember the words, right? I really believe in writing things out. Nowadays with so many electronics, people like to type their notes out, but I think writing it out, there is something about writing that wire with your brain's memory. It helps you remember things a little bit better. So I mean, I don't know. It sounds cliche, but I think that's how I studied when I was in school, and just write things out many times. Hopefully that will help a little bit, but I know it's a lot of information. Okay, so let's come back to here. The pharynx, right? The pharynx is AKA the throat. Okay, the throat. I'll just put here the throat. Okay, so two openings that lead. Sorry, my grammar is not too good. Into the pharynx. Okay, and we already know what they are, right? It is the nasal pharynx for air and oral pharynx. Okay. And then what does it actually do? Well, it is the common passageway. Common passageway. Okay. For air, food, and liquid. Okay. They all passes through the same thing. Probably need a space here. Common passageway. Okay. And then it leads to the larynx, as well as what's the passageway that goes down to the stomach, huh? What is that called? Anybody? So
esophagus.
Esophagus, thank you. Esophagus. Okay. Some people spell it with an O at the front. It's okay. It's one of those like, multiple spelling things like color.
O with, I think, British probably.
Yeah. It's like color, right? With a U or without a U, right? Or like center, right? Some people spell center ER, some people spell RE. It's one of those things. English is more complicated than biology. Okay, so larynx. Larynx is the voice box. Voice box. Okay. So what do you find in the voice box? Well, larynx is going to contains the vocal cords. Okay, vocal cords are muscles that you can control, right? Skeletal muscles. By changing the tension in the vocal cords, you can have like high pitch or low pitch, right? So if it's tighter, it's going to be higher pitch. If it's more thicker, then you're going to have a lower pitch. I don't have I shown you guys a video of someone's lyrics in the lecture? I don't remember. Did I show you guys that?
No.
No. Okay, so let me quickly search that up for you right now. It's quite interesting. So there you go. Okay. I have not done this before, believe it or not, sharing the video like this. Let me see if I can share the sound Okay, let's see if this is gonna work. Okay, now this might gross some of you out. Okay, so like if easily grows out, just don't watch. Okay, cover your eyes. So do you guys see? Can you guys hear the sound? This is actually the vocal cord, right? Okay, so you can see the rings here. Can someone tell me what those rings are? Anybody? What are those rings? What am I looking at here?
This is the tracheal ring.
That's right. Those are the cartilage rings, right? That are protecting your trachea, except we're looking at it from the inside, right? This is called laryngoscopy, right? It's for people to check the vocal cords of someone, right? And what about this thing here, right? This semicircle U-shaped structure. Anybody know what that is? No? That is the epiglottis. Okay, that's the one that's going to be covering this whole thing when you're swallowing. Okay, if you put your throat here, right? Put your throat on your neck. Okay, you can feel your larynx. Okay, you can feel the thyroid cartilage that protects your larynx. Go ahead, put your hand there, and I want you to swallow. Okay, just put your hand there and do a swallow. Do it. Okay. When you swallow, how do you feel? What do you feel? Do you feel anything? Do you feel something is moving? Yes, it goes up, right? So like the epiglottis is here, and then when you swallow, it actually goes up, and then it gets sealed, okay? Some people have this misconception. They think the epiglottis is like a toilet seat. It goes up and down, right? When you swallow and not swallow, okay? But epiglottis actually doesn't really move, okay? It's the larynx that goes up, and then it gets sealed. Maybe I'll show you another clip later. But here, look at the vocal cords and try to listen to the to the pitch, okay? Do you notice like when she did the high pitch, it's a lot like thinner, and then now when she's doing the low pitch, right, it's a lot thicker. Okay, so that is the vocal cords. Okay, I mean it's kind of cool. I think I had one of these things done. To me, quick story. When I was a kid, I must have been like 6 or 7, I think, because this is according to my parents. Like I like to throw tantrums a lot apparently when I was young, and so I scream a lot to the point that my voice became very raspy. And so, you know, even when I'm just normally talking, my voice was very, very hoarse, like sounding. Okay. And so they took me to this throat doctor, right? There are these specialists that specializes in the throat, the ear, and the nose. I don't know what the proper title is. I was just calling
ENT. They call ENT. ENT,
ENT?
ear, nose, and throat. Yeah.
Oh yeah. That's right. Okay, so I was taken to one of these specialists, and what happens was I remember the doctor took one of the endoscope, which is like a flexible tube, right? And he inserted out my nose. Remember, I was 6 years old, okay? And then there was no, anesthetics or whatever. He just stuck it up my nose. And then what's really traumatizing for me was that I can see the whole thing going on like a screen. Because I guess he was trying to show like my mom, right, as well on the screen, and then the feed the tube in, and then I was able to see something like this on the screen, and then I know that that's like me on the inside, which is traumatizing, trust me. So the whole thing goes in, and then they actually found a little knob that was growing on one of my my vocal cords, and he said it was a scar tissue that has formed because of all the screaming. So he has a wonderful solution for my parents. Your son's not allowed to talk for the next, I forgot, whatever, right? X amount of period, and then it will eventually heal. My mom took advantage of the whole traumatizing experience. He said, if you throw a tantrum and start screaming again, I'm gonna take you back to the throat doctor, and then you're gonna have to have something stuck up your nose. So I think I didn't throw as many tantrums apparently afterwards. And as you can tell, I sound fine now, right? Okay, so I assume the scar tissue is gone. Yeah, but you guys know Adele, right? Like the singer, right? Like she said she had one of these things done to her to see if her vocal cords was damaged at one point. So that's that. Anyway, let's show you another one, and then we're gonna move back, right? This is an X-way swallowing, and it's also quite cool, right? You can see there is the uvula, and then here is the epiglottis. Okay, you see when you swallow, the larynx actually pushes up, and then it closes the trachea, so the food can go down in the esophagus. Okay, this is like the front view, which you can't really see as much. Okay, but the side view you can see clearly. Okay, again, this is the epiglottis, and then the larynx pushes up as the food goes down. Okay, so that is that. I hope it was entertaining. Any comments or questions before we move on to the more mundane stuff? Fantastic. Okay, so this is the larynx. So it contains the vocal cords and the opening to the larynx is called the glottis. Okay, and what happens is the larynx pushes up against the epiglottis during swallowing, so we don't choke. Okay. So epiglottis, we already talked about it. It's basically an elastic cartilage that covers the glottis. Okay. And again, right, as you saw in the video, the epiglottis is not the one that's doing the motion. Okay, it is the larynx that's doing the motion. Okay, trachea now. Okay, trachea is anterior to the esophagus. Okay. It is covered, protected by C-shape cartilage. Okay, the reason it has to be C-shaped is because the esophagus is behind it, right? So you don't want to restrict the esophagus as well. You just want to protect the trachea. Okay, so the difference between the esophagus and the trachea is the size. Okay, the trachea is much bigger, and also when you are not swallowing, food or liquid, the esophagus stays closed. Okay, but not the case for trachea. The trachea must be opened at all times, and to keep it open, you need to have the C-shaped cartilage. Okay, so on the inside, right, the inside of the trachea is lined with two types of cells. Okay, we have the ciliated pseudo stratified columna. Okay, so you might remember learning this last semester, but basically columnas are like rectangular cells. Okay, ciliated, so they have cilia on it. Okay, and stratify means multiple layers, but these are pseudo stratified, which means they look like it's multiple layers, but actually it's just one layer. Okay, so that's what the inside is made up of. And also these goblet cells. Okay, so goblet cells secrete mucus, which would trap, dust particles, pathogens, and then the ciliated cells is going to sweep them up, right? So together they work as your defense, right? Immune defense, your physical barriers, basically. Okay, so that is the trachea. Next, we're going to have the bronchus. Okay, Okay, so the bronchus. The trachea is going to branch into the bronchus, and the main bronchus, the main bronchi, the left and the right one, leads into the lungs, where they continue to branch into secondary and tertiary bronchi. Okay, the further you go, the more branching you have, the more narrow the diameter is going to be. Okay, in terms of the structure, right, it's similar to the trachea, right? Also protected by cartilage. Okay, the difference is that for the main bronchi, the primary bronchi, both means the same thing, as well as the secondary, instead of having C-shaped ring, they will now have full circle rings. Okay, and then when you get to the tertiary bronchi, it's quite small. Right? The tertiary bronchi are quite small, so instead of having like full rings, they would have these cartilage plates. Okay, so they're just like little fragments of cartilage that goes around the tube. Right? So you have the cartilage plate. Okay, because having a full ring is going to be too restrictive. Right? So just having little plates there would serve the purpose of providing support, but not overburden the structure. Okay, so the plates will exist on the tertiary bronchi. The main and the secondary will have the full C-shaped ring. Okay, so when people get bronchitis, it is the inflammation of the bronchus. Questions? Okay.
Professor,
Yeah.
can you please zoom in? I want to take a screenshot.
Oh, sure, sure. Is that okay? I think that's as much as here. Let's just there. There we go. Okay. Let me know when you're done.
I'm done. Thank you.
No problem. Okay. Let's keep going. I don't know why there's the nasal cavity here. I should take that out. Okay. I think I just copy and paste the table from above and then forgot to erase it. Next, we have the bronchioles. Okay, bronchioles are the smallest diameter, smallest diameter of the airway. Right, so we started at the trachea, and every time it branches, it gets smaller and smaller until we got to the bronchiole, which is very, very small. Okay, so less than 1 millimeter. Okay, less than 1 millimeter. Okay. So because they're so small, they do not have any cartilage ring, cartilage support. Okay, therefore they can collapse. Okay, they can collapse, especially during asthma attack. Right, so that's why you need the puffers. The puffers are called bronchodilators. It relaxes the smooth muscle and it allows the airway to open again. Okay. So at the end of the bronchioles, it will lead into the LVO line. Okay, so located at the end of bronchiole. Okay. This is the site of gas exchange. Okay. So the oxygen from the air is going to go into the blood, and then the carbon dioxide from the blood is going to go into the LVO line, right? The airway. It's going to go back up. Next, we have the pleurae. Okay. So it's like a double membrane that surrounds the lungs. And we have the visceral pleura, which is directly in direct contact with the lungs. Okay, that we can say the inner one, the inner layer. Okay, the one that's touching the lungs. And then we have the parietal pleura, which is the outer layer. Okay, just like the heart, right? Visceral, pericardium, and parietal pericardium. Now, in between, right, there is the pleural fluid between the two layers. Okay, so the pleural fluid, it creates surface tension so that when one layer moves, the other layers will move with it. Okay, think about two plastic bags. Okay, if you have a plastic bag on the table and then you have another one that you're holding, you can try to pick up the plastic bag with the one that you're holding. Like they just won't stick, right? Okay, but if you wet it first and then you try to, you know, touch the other one, you might be able to lift it up. Okay, that moisture is going to help create surface tension that allows two things to stick together. Okay, otherwise they might not stick together, and we want them to stick together so that it will move in unison. Okay, that is important for breathing, and I'll explain more later on.
I have a question.
Yes, please.
Going back to the voice box, you know, they have some people who actually uses like a little device when they're speaking.
Yeah.
Is
So
that because
yeah, go ahead.
is that because the voice box has been damaged, or?
Yeah, so like some people with cancer, for example, right? They cannot speak anymore because of throat cancer. That's one reason, and that machine that you're talking about, I forgot what it's called, but it basically helps amplify the vibration and the sound. Like you can still, those people, I think they can still speak, but it's just that it's the damage caused it to be inaudible for most people. So that device basically serves as like a microphone, if you would, right, to help speak. There is also the other one that I think I show in the lecture that some people have a hole here, right, in the trachea. Did I show that in the lecture?
Yeah, but isn't that when they can't breathe, then you just put that hole?
Yeah, exactly, right. So then for some people with the hole here, because the hole is below the voice box, so you know sometimes the air would escape before it goes through the vocal cords, and you know they would not be able to, they would have to learn how to speak, or they would have to put a little valve here that will not let air escape, and so you know that way they could talk. Okay, but it's basically a similar concept here. Okay, now most of us are here, so I want to talk about what's going on next week. Okay, and for those of you watching the recordings, you know, you can find this information online. So there are several important changes next week. Well, not changes, but like things that we have to keep in mind. The tutorial for next week is going to be Monday instead of Wednesday. Okay, there's no new lecture that you have to watch next week. Right, we just got to take it easy, do a review on Monday, and then we will have the test on Wednesday. Okay, so during the review, I will take up the online lab. Okay, so here's the hyperlink for the lab. You can click on it, and I think I explained this at the beginning of the semester already. But then I received a few emails from people who are asking me what's going on with the lab. Just to reiterate, the lab itself is not worth any marks. Okay, you answer these questions, you do not have to send me the answers. Okay, we will take up these on Monday. Okay, the tutorial class. So if you do it first and then come, it will make more sense. Okay, we'll just be taking up the answers and you can ask questions. Okay, so do that. And then after the tutorial on Monday, you will be able to do the lab quiz. The lab quiz is based on the lab as well as you know, the lecture material. Okay, so like some multiple choice questions, for all the units that all the lectures that we have done so far, including the cardiovascular system. Okay, that one is 2.5%, and you will have access to it on 2 days. Right, you will have access to it on Monday 10 a.m. all the way to Tuesday 10 p.m. Okay, and you can do it 2 times. Right, and only the best score will count. So if you get 65 on the first try, and then you get 80 on the second try, your final mark would be 80%. And this is worth 2.5% of your final grade. People usually do very well in these lab quizzes, okay, like 95 or 100, okay? Now, if you got like 95 on the first try, maybe I suggest don't do another attempt, okay? Because it's you know, it's a little waste of time, right? Like even if you get 100 the second time, it's only 2.5%. It's not going to substantially change your grade. But you know, if you have a lot of time and you don't mind the practice, you could. But I'm saying I wouldn't. Okay. And here are information for the first test. It will be next Wednesday, available from 10 to 10, 75 minutes this time limit. And it will be only from lecture 2 to 4. So no cardiovascular systems. Here are the breakdown of the question types. Right? We will have some multi-select, some application, and it will be 20% of your final grade. The quiz is out of 45. And again, if you register with CALS, I think you contacted me already. And if you haven't already, please do so. So that's the information for next week. Any questions, concerns, comments? And then after this, it is going to be engagement week, like I said. Okay, so there's nothing happening in the engagement week. You just take a week off and take it easy. Okay. All right, let's go back to our thing here. Okay. Next, 4 factors that affects airflow. Briefly describe how each affects airflow. Okay, so the first factor that affects airflow, anybody remember? Anyone? Help me out here. No? Okay, so the first one is Boyles Law. Boyles Law. Okay, so what's Boyles Law? Boyles Law states that at constant temperature, when volume increases, the pressure will decrease. Okay, and vice versa. That means when volume goes down, then pressure is going to go up. So this is Boyles Law. Okay, so this would be important for airflow because by changing the pressure inside our lungs, we can control which way the air will flow. Okay, so by changing the lungs pressure, we can control the direction of airflow. Okay. Second factor is pressure gradient. Okay, gradient is just a fancy word for difference. Okay, so in general, air flows from an area of high pressure to an area of low pressure. Okay, it's kind of like diffusion, right? Go from area of high concentration to an area of low concentration, right? Except we're talking about pressure right now. So there are two pressures that we're interested in. We have PI, okay, PI and PA. Okay, so for those of you who don't quite remember, PI is intrapulmonary pressure. Sorry, it's a little bit crowded here. PULMONARY, intrapulmonary pressure. That's basically pressure inside your lungs. And PA, it is atmospheric pressure. Okay, like pressure outside. So here, if PI, if the pressure inside the lung is greater than PA, will the air rush out or will the air rush in? What do you all think?
In.
Okay, so Colleen says in. Anyone else? Do you agree or? Okay, so Stephanie said out. We are 1-1 right now. Let's do a poll. We haven't done the poll all day yet. Okay, so launch the poll. There we go. If you think it's gonna go in, please choose A. If you think it's gonna go out, please choose B. If you're not sure, choose C. Okay, I'm just waiting for more response. All right, I'll end the poll. Okay, let's take a look at this again. In general, air flows from an area of high pressure to an area of low pressure. So if the lung pressure, PI, is greater than, this symbol means greater than, right? So if the pressure in the lung is greater than the pressure outside, then according to this, the air will go from your lungs to the outside. So this one, air rushes out, okay? Out of the body. Does that make any sense? All right. The opposite is true. If PI is less than PA, if the pressure in the lungs are smaller than the pressure outside, then air rushes into the lungs. So this is the condition that you need to create if you want to breathe out. And this is the condition that you need to create if you want to breathe in. That is pressure gradient. Next one, we have compliance. Okay, compliance basically means the expandability of the lungs. Okay, something like a tin can. Okay, it's not very compliant. You put air in, it's not gonna expand. Right, it's not gonna change the shape. Okay, something like a balloon, it's compliant. When you blow air in, it's able to expand and accommodate the extra air. Okay, so compliance is important because it will help you accommodate the air. Okay, the compliance of the lung is dependent on the amount of surfactant. Okay, so these surfactants are like oily substance that helps the lung open up. More surfactant generally means higher compliance. But you might remember in the lecture that I said too much surfactant is actually not good. And we will review that in a second. Finally, does anybody remember what the last one is? Last factor that affects airflow? Anybody?
Resistance to airflow.
That's right. Last one is resistance. Thank you. Resistance. Okay, so resistance is basically how obstructed the airway is. Normally is not really obstructed, okay? But when you have a cold, when you have allergy, when you have asthma, all those mucus secretion, it's gonna increase the resistance. So basically, resistance is related to the diameter of the airway. Okay. So, for example, if you reduce diameter because of, again, mucus buildup, or like you physically have something obstructing your airway, right? Then that equals to increase resistance, which equals to more difficulty breathing. Oh my goodness. And of course, the opposite is true, right? If you increase the diameter, you will lower the resistance and it will make it easier to breathe. Okay, so there you have it, 4 factors. If you want to take a screenshot, you can. And if you have any questions, please ask. Okay, moving on. So this is talking about surfactant and surface tension, and this has to do with the LVO line. So let me just quickly review this concept with you. Okay, so your LVO line, it's basically like a spherical shape LVO line, and the inside is moist because we need to have a moist surface for the gas in the air to dissolve in before they go into your bloodstream. Right? So we need to have a moist surface. But by having a moist surface, we create a little bit of a problem. Right? Water, as you learn, is polar, right? In chemistry class, the oxygen is slightly negative, and then the hydrogens, they are slightly positive, which means if you put 2 water molecules next to each other, they will be attracted to each other. So that attraction, it's going to create what we call surface tension. Right? So the surface tension will cause this water molecule to pull on this one and pull on this one like this. And in if you consider the forces together, it creates an inward force that will cause the LVO line to collapse. Okay, think of having magnets, right? Inside of, if you glue magnets on the inside of a bag, then it will, cause the bag to collapse. So that is the surface tension created by the water. Okay, created by the moist interior of the LVO line. Okay. Alveolus, singular. How is it going to affect respiration? Do you think this will help with breathing in, or is going to help with breathing out? Let's do another poll. Do you think it's going to help with breathing in or breathing out? Okay. My question is, will the surface tension help with breathing in, or will it help with breathing out?
So the A is breathing in and B is out.
A means it will help, the surface tension will help with breathing in. B means the surface tension will help with breathing out.
Okay.
Yeah. Okay, I only have 6 response. Please make a choice. If you're not sure, you can choose C. All right. So I know that you're there. Some of you tell me you cannot see the polls on the phone, which is fine. Okay, so most of you got it. The water surface tension, again, look, the alveoli is like this. If the surface tension helps you close the alveoli, it will squeeze the air out, right? So this is going to help with exhalation, breathing out. Okay, but it will go against inhalation. Okay, because in order to put air in, right, in order to breathe in, you have to kind of counteract all these forces, right? You have to physically, pull the surface tension apart in order to infuse the air. Okay, so that's that. Now, if this is the case, then we would have a hard time breathing in all the time. Okay, it would be very laborious. And so nature has a way to counteract this. And you have some cells, okay, in the lungs called the septal cells. And the septal cells will secrete surfactant. Surfactant is an oily substance that will break some of these surface tension, and it will create like an opposing force that allows you to open up the alveoli. Okay, so the surfactant is created by septal cells. Okay, it is an oily substance. Effect, well, you're breaking the surfactant. The surfactant is breaking the surface tension, so it will increase compliance. Okay, help with inhalation. Right? If you have a more compliant lung, you can blow it up easier. It will help with inhalation. But too much is not good because it will go against exhalation. Okay. If something is too compliant, then you reduce the elasticity. Okay, so it won't be able to squeeze out the air as much. Okay. Questions before we move on? Anyone?
So the person who has asthma,
Mm-hmm.
do they have connection with it?
Do they have connection with what? Sorry.
Yeah, this surface tension and something like that.
Oh, okay. Yeah. So asthma is not really related to this
Okay.
concept. Yeah, asthma is primarily related to resistance. Okay. Yeah, because during an asthma attack, you have a lot of mucus being secreted, so that will reduce the diameter, making it more difficult to breathe. Right. In addition to the mucus, the airway is the bronchioles specifically will also close in, and that will further exacerbate the problem. Okay, so not so much related to this. Good question. Okay, let's do a quick poll, and then we'll take a quick break, and then we'll see what's going on after. Okay, go ahead, relaunch the poll. There we go. Oh, sorry. This one is select all correct answers. So it actually has to be multi-select. Go ahead. So the lower respiratory tract would be bronchus and trachea. Everything else is above. It's part of the upper respiratory tract. Remember the cutoff is the larynx, right? The larynx is the last part of the upper respiratory tract. Okay, let's try the next one. Which of the following separates the nasal cavity from the oral cavity? Okay. Again, most of you got it right. It is that hard palate. It's made of two bones, the maxilla and the palatine. Okay, next one. Okay, the correct answer is the thyroid cartilage. And let me see if I have a picture of that. Yeah, right here, right? Okay, so this is the thyroid cartilage. Okay, this here, that's the one that you feel when you put your hand in the throat. Okay, that's the thyroid cartilage. It's already labeled in the lecture recording. And then this is the cricoid cartilage, and the hyoid bone is up here, okay, which you can't really see. So what's protecting the larynx is really the thyroid cartilage. Okay, that's the answer. Thyroid cartilage, not the hyoid bone. Hyoid bone is higher up, right? Hyoid higher up. Okay. Let's see. Okay, number 4. Superficial means outside of, okay? Okay, only have 4 or 5 response. Anyone else? Okay. Let's look at them. Visceral pleura is superficial to parietal pleura. That's not correct. Okay, it should be the other way around. Visceral is the one that is inside, so it is deep. Opposite of superficial is deep. Right? It's deep to the parietal pleura. The trachea is posterior to the esophagus. It's again the other way around. Trachea is in front of the esophagus, so it should be anterior. The diaphragm is superior to the lungs, on top of the lungs. Not true either, right? Diaphragm is below the lungs, so it should be inferior. So these three are not correct. And the lungs are lateral to the hearts. Heart in the middle, lungs on the side. So that is correct. Let's just do one more. Okay, so increasing volume will increase the pressure as well if temperature is constant. It's not true. It's supposed to be the other way around, right? Inverse relationship. If you increase volume, you will decrease pressure. That's not true. Increasing lung compliance will make it easier to inhale. Compliance is the expandability of the lungs. So the more expandable it is, the easier it will be to inhale. Let's take a look at why the other ones are not correct. Reducing the airway diameter will increase resistance because now it's more narrow. It's harder to go through, more resistance. Air will naturally go from high pressure to low pressure. All right, that's that. Okay, that takes us to 9:40. Let's take a quick break. We will resume at 9:45. All right, let's keep going. So next thing here, circle the correct description for inhalation and exhalation. Let's go through the mechanics of breathing in and breathing out first. Now, let me grab a piece of paper here. I only have a stack of paper here. So this is like your diaphragm. Okay, your diaphragm has two shapes. It's either dome shape like this. This is the natural state of the diaphragm, if you would. It's relaxed and it's dome shape. Okay, so if you want to breathe in, if you want to inhale, then you have to contract the diaphragm, which causes it to flatten and move down. Okay, and because of the pleura, when the diaphragm contracts and moves down, it will pull the lungs down with it. Okay, so breathe in and then breathe out. Okay, contract, breathe in, relax, breathe out. Okay, flatten when you're breathing in, and then dome shape when you want to breathe out. Okay, so by moving your diaphragm, you're pulling the lungs down with it. Oh, you're not seeing anything? Oh, you mean my screen? No, I am sharing my screen. Anyone have the problem not seeing me?
You're drawing. We're not seeing you drawing.
Oh, I'm not drawing anything. I was just moving the paper to for you to see. Okay, yeah. Okay, so that when the diaphragm moves up and down, you pull the lungs with it, or you push the lungs up. That will change the volume of the lungs, which in turn will change the pressure. Okay, so the second thing that will be important is your chest. Okay, so your rib cage. If your rib cage moves out, it will pull the lungs with it, and if your rib cage goes down, it will compress the lungs. Okay, so collectively, okay, let's say this hand is the rib cage, and this hand is the diaphragm. Okay, so if you want to breathe in, diaphragm has to go down, and then the rib cage has to go out. So together, it will pull the lungs with them, expanding your lungs. Okay, and then if you want to breathe out, it will be the other way around. So breathe in, breathe out. Okay, so how does it look? Well, let's try to draw it out to see. Okay, so this is the person. This is the person. Okay, and if you want to breathe in, right, this is exaggeration. Okay, so that you can understand better. If you want to breathe in, two things needs to happen. The rib cage will go out and up. Okay, this is the rib cage. Rib cage, and you have muscle that helps you do it. Okay, when you eat ribs, you're basically eating the muscles of the cow or the pig that controls the rib cage. Okay, so out and up, and then at the same time, your diaphragm. This is your diaphragm. Diaphragm is gonna go down. Okay, diaphragm. It's gonna go contract and then move down. Okay, so collectively, it will pull the lungs with it because of the pleura, because of the fluid, right, that we talked about. Okay, so the visceral pleura will be connected to the lungs, but then the parietal pleura will be connected to the rib cage or the diaphragm. So when the parietal moves, it will pull the visceral with it. So collectively, what's going to happen is this will increase your lung volume. And by Boyles Law, we know that this will drop the lungs pressure, okay, decrease PI. Right? So for breathing in, you will move the rib cage up. You will flatten the diaphragm. And these actions collectively will increase the lungs volume. By increasing the volume, you will drop the lungs pressure. So when PI is less than PA, you inhale. Okay? So in the lecture, I mentioned a lot of times people feel like, you're breathing in and then your chest goes up, right? But as I just explained to you, it's the other way around. In order to breathe in, your chest must move up first, along with the diaphragm. Okay? Which is why if you have something on top of you and you can't move your chest, then it's very difficult to breathe, right? Because with limited chest motion, you won't be able to change the pressure of your lung as much, and therefore not as much air will come out. Okay, so you guys know that the I think it's called boa constrictor, like the really big snake, right? This terrible drawing, never mind. Like the boa constrictor, right? They actually wrap themselves around the prey. Okay, so what happens is every time their prey, like a little bunny or whatever, every time the prey breathes out, right, they go a little bit tighter, and then a little bit tighter and a little bit tighter, right? Then and force them not to be able to move their rib cage, right? And by not moving the rib cage, they won't be able to breathe in, and that's how they kill their prey. Okay. On the other hand, if you want to breathe out, okay, what you're gonna do? Well, what you're gonna do is, again, this is exaggeration. What you're gonna do is you will push your diaphragm back up, right? So your diaphragm will relax, and then it will move up, and then your rib cage is going to come in and down, right? So collectively, it will compresses your lungs. It will drop the volume. It will increase the pressure. So when PI is greater than PA, you exhale. Okay, so down, dome shape, drop the volume, increase the pressure. That's what happening when we are breathing. Okay. All right, moving on. Next, we have a bunch of volume here. Now, I already labeled this in class, so I'm not going to go through that again, but I'll draw it from scratch to sort of help you understand it. Okay, for those of you who need a refresher, or if you you know, haven't watched the recordings yet. Okay, so this would be like volume of the lungs, and this is just like time. Okay. So as you are sitting here for the past, I don't know, hour and a half, what's happening is you're breathing in and out quite regularly. So air goes in, goes out, goes in, goes out, goes in. Okay. So that change in volume is what we call tidal volume. Yeah, that's just the regular amount of air that goes in and out when you're not doing anything special. Okay. Now, let's do this together. Okay. After you breathe in, your normal breathe in, let's breathe in as much air as you can. Okay, so 1, 2, 3, all the way until you can't breathe in anymore. Okay, so that extra bit of air that you just breathe in, that extra bit of air that you breathe in beyond your normal inhalation, that is what we call the inspiratory reserve volume. Okay, it's right here, inspiratory reserve volume. I'm just going to put IRV. Okay, so that's the extra bit of air that you can inhale. All right, so now exhale, back to normal. Okay, back to normal. Okay, now what you can do next is at your next exhalation, you can breathe out as much as you can. So all the way until you can't breathe out anymore. This is like yoga class. Okay. So at that point, right, you go down all the way. The extra bit of air that you just breathe out, that is called the expiratory reserve volume. Okay, expiratory reserve volume, ERV. Okay, and then you can go back up to normal. Any questions so far about the three volumes, the tidal volume, the IRV, and the ERV? Okay, so suppose we breathe out as much as we can, all the air out, then you're going to be at this point. From that point on, now you breathe in as much as you can. So all the way back up to the top. Right? So you just went from the lowest possible point to the highest possible point. Okay, that is the vital capacity. That is the maximum amount of air that you can voluntarily move into and out of your system. Okay, so vital capacity equals to inspiratory reserve volume plus tidal volume plus expiratory reserve volume. Okay, this is your normal breathing in and out. This is the extra bit that you can breathe in, and this is the extra bit that you can breathe out. If you add them all together, you get the total amount of air that you can voluntarily move in or out of your system. Okay? Now, even after you breathe out as much as you can, there is still going to be some air that is left. Okay? So this amount of air that is left is called a residual volume. It is very concentrated in CO2, right? Those air don't come out. Right? When you breathe in and out, these are just, actually they are called dead air. Okay, dead air, okay? Because it's not useful for gas exchange. It's just very rich in carbon dioxide, and they never really breathe out, okay? Come out. The only time the residual volume comes out is if you pop the lungs, If there is some kind of puncture wound, so there's a knife, or if your rib cage break and puncture your lungs, then the residual volume comes out. And even then, even after the residual volume comes out, you will still have a bit of air left in the lungs. That is called a minimal volume. Okay? So those are your volumes, the volumes that you should know. So let's go through this here. First one, the maximum amount of air that can be moved into and out of the respiratory system in a single respiratory cycle. Right? So as I just explained to you, that would be the vital capacity. It is actually 3 separate volumes added together. Next, the amount of air that could be voluntarily expelled at the end of each respiratory cycle, that is the expiratory reserve volume, or ERV. Amount of air left in the lungs after it collapses, that is the minimal volume. The amount of air that can be taken in over and above the resting tidal volume, that would be the inspiratory reserve volume. The amount of air moved into or out of lungs during single respiratory cycle, tidal volume. And finally, even after you exhale as much as you can, if your lungs are not collapsed, the amount of air left would be the residual volume, the dead air. Right? You don't want too much dead air in your system. Right? They're useless, rich in carbon dioxide and useless. Question? Anybody before we move on? All right. Hope everyone is still with me. Now, there are a couple questions here. I don't remember if I talked about it in the lecture, so let's just quickly go through it. When you're exercising, how are the tidal volume? This should be tidal volume, IRV, ERV, and vital capacity affected. Okay, so when you're exercising, right, what happens to your TV? Okay, what happens to your IRV, and what happens to your ERV and your VC? So tidal volume, what do people think? Does it go up, go down, or unchanged? Yeah, tidal volume is going to increase, right? Because then you are going to be breathing, you're going to be requiring more oxygen, right? Like that, right? So it'll be more rapid, right? Yeah, as opposed to like this, right? Very calm. It'll be more rapid, and then you'll be taking in more air. Okay, so the tidal volume will increase, and then the IRV and the ERV would increase. Okay, so if you increase the tidal volume, then you can see the new ERV and IRV are going to be smaller compared to before, right? Compared to before. Okay, see the new one is going to be shorter, right? Because you're eating into their volume. What about vital capacity? Do you think vital capacity will change? Increase, decrease, no change? What do you think? Okay, Joan, Colleen said unchanged. That is correct, unchanged. Okay, so because VC is the sum of all these things together, and if you increase tidal volume and then you decrease the other two, the final won't change. Okay, this is like the amount of income that you have in a month. Okay, if you spend more on food and then you spend less on other stuff, entertainment, rent, whatever, the income's not going to change, right? Okay, this is just like you redistribute the volume. Okay, next one. For someone who suffers from emphysema, what happens to the residual volume? How will this affect the person? Can someone explain to me what emphysema is, please? What is emphysema? Anybody? Abdullah said losing internal pressure. Okay. Anyone else want? Yeah, Colin, go ahead.
The sac in the lungs are damaged.
Okay, yeah. So the alveoli, and Jung agrees with you. Alveoli are damaged. Okay, and then they merge together, and then it creates large empty spaces. Okay, and then what happens is it will also lose elasticity. Okay, so what happens is instead of having like a few, and I don't really know how to draw this nicely. Instead of having like, a cluster of healthy alveoli, if they're damaged, then they become like a big empty space like this. Okay, it's all broken up. So this empty space will cause the air to be trapped. Okay, trapped air. So all these air will now become your dead air, your residual volume. So for someone who had emphysema, you will increase the RV. And to make the problem worse, you won't be able to squeeze out these air because you lose the elasticity, right? So before we have like 3 alveoli, they each have surface tension that will help squeeze out the air when you breathe out. But now you merge them together, it just becomes one big empty space. There's no squeezing action going on. So you end up trapping more air, and you're not able to exhale it. Okay, so like as a picture to show you. Okay, so think of the lung as a tube, right? Okay, so before, and these are totally random numbers. Okay, let's say you have this much residual volume. Let's say this is like 2% or something residual volume. That means you will have 98% capacity to do air exchange. Okay, so you can breathe the air out, you can refill it, breathe the air out, refill it. But now, because of the damage alveoli, you would increase your residual volume, I don't know, to like 10% or something, and then you will only be left with 9%, 90% of volume for gas exchange. All these 10% will just be dead air, will just be carbon dioxide. They would not help you with the gas exchange. And so over time, if you keep on increasing the residual volume, then you'll be breathing, but then you would have shortness of breath because you're not getting enough oxygen into your system. Does that make sense? Okay, the person will have more difficulty breathing out. Without the elasticity, exhalation become laborious because you have to physically like breathe the air out, like force the air out. You have to, push the diaphragm extra out and extra up, right? And then you have to press your rib cage extra down, right, to squeeze all that air out. Okay, compared to if you have, healthy alveoli, the elasticity will automatically does that for you. And so the analogy people usually use is, healthy lungs is like blowing air into the balloon. You let go of the neck, air comes out normally. But for people who suffer from emphysema, it's like breathing air into a paper bag. Okay, you blow it in, the air just stays inside, right? To get the air out, you have to like squeeze the bag, right? So that is emphysema. Okay. All right, next. The respiratory center in the medulla oblongata, which is part of the brainstem, detects O2 level to regulate breathing rate. Is that true or false? Is that true or is that false? Let's say false. That's right. And the problem is it's supposed to be CO2. Okay. The brainstem, the medulla oblongata, detects the amount of CO2 in your system. If there are too much CO2, then it initiates breathing. Okay. Oxygen is not going to affect your medulla oblongata. Okay. Oxygen is going to be detected by something else called the carotid bodies, right? Carotid bodies, which are located in your carotid artery, right? As well as your aorta. that detects the amount of oxygen, and it serves as like a backup system to remind the medulla oblongata to breathe when your oxygen level is substantially low. But on the test, if I ask you what gas is responsible for driving respiration, make sure you choose carbon dioxide. That's the main gas that contributes to our breathing pattern. Next, the diaphragm relaxes during inhalation to increase the volume of the thoracic cavity. So to breathe in, you actually have to contract your diaphragm so that it's going to move in, it's going to flatten and pull your lungs out, pull your lungs down. So that is false. Air rushes into the lungs when PA is greater than PI. Is that true or false? Hopefully it makes sense by now, right? Yeah, this is true. Okay, goes from high pressure to low pressure. Vocal cords are found in the pharynx. That is not true. It is supposed to be found in the larynx. Okay, I used to get confused between the two, right? But someone tell me, right? Vocal cords for singing, and when you're singing, you're like la la la, right? So that's the larynx. Vocal cords in the larynx. Trachea is anterior to the esophagus. We know that is true. According to Boyles Law, pressure increases when volume decreases. So that is false. Inverse relationship, right? But the key thing is the temperature has to be constant. Next, the trachea, bronchioles are all covered with cartilage. Not true. Bronchioles do not have cartilage. That's why they are at risk of collapsing during an asthma attack. The parietal pleura is superficial to the visceral pleura. That is true. And I think that is all for the true or false. Okay. Do we have more polls?
Professor,
Yeah, go ahead.
can you please zoom in? I just
Oh.
want to take a screenshot of that.
Sure.
I'm done. Thank you.
Okay, yeah, I'll post this after class as well, right? Like last week I did. Polls. What's going on here? Okay, so let's see if you if all of you paid attention. Go ahead. This is straight textbook question. Really? Only 5 of you wanted to answer? Okay, I will end it then. It is the expiratory reserve volume. Okay, that's the extra bit of air that you can breathe out at the end. Okay, you want to try this one. Trust me, you do. Okay, go ahead. Okay, maybe a couple more seconds, half more minute or so for people to figure this out. Okay, so let's see how to do this. We have a bunch of information here, but there is one formula that you should know. It is the vital capacity is IRV plus tidal volume plus ERV. Okay? So the vital capacity is 6,000. We are trying to find IRV. Tidal volume is 500. And ERV is 1,000. Okay, and this is just extra information that we don't need. Okay, total lung capacity would include things like residual volume and minimal volume. So here, I'm sure you learned how to do this in math class. 500 plus 1,000 is 1,500, and you move it to the other side, right? That's going to be 4,500. Any question about how to calculate these things? Okay, make sure you know how to calculate it for the test, okay? I'm sure you will run into a question like that. Okay, last one here. Let's take a look. This one is a little bit intense. All right, it has been 2 minutes. I'm gonna stop the poll. And only 5 of you have answered. It is a little bit challenging here. Let's take a look at the question. Dawn is not able to produce surfactant. So as we know, surfactant is gonna help with, surfactant is going to help in inhalation, right? Inhalation by breaking surface tension. So if you follow this logic, then not having enough surfactant means you would have a hard time breathing in. Okay, so how do you fix this? In order to have normal tidal volume, she will need to inhale more forcefully to lower the intrapulmonary pressure. That's the correct answer, right? Because she cannot inhale properly, right? So she must do it forcefully, right? She will need to exhale more forcefully to empty her lungs. This would be the solution for emphysema. Okay, so if on the test the question asks you what happens for someone with emphysema, then B would be the answer. She will need to breathe air with higher oxygen content. That is also maybe something for emphysema, right? As well as we talk about like COPD in class, right? Chronic obstructive pulmonary diseases, which is chronic bronchitis plus emphysema. Then you need to carry an oxygen tank, okay? Because remember, in emphysema, your dead air it's higher, right? The percent of residual volume is higher, so you won't be getting enough oxygen in your system. So breathing more oxygen would potentially help the problem. She can just breathe normally. No, that is not true, right? Okay, surfactant does affect tidal volume, as I just explained here. So that would be the answer. Okay. All right, let's finish with the fill in the blanks here. Okay, first one, the pharynx. The pharynx is the common passageway for food, water, and air. The opening that leads to the larynx is glottis. Glottis. And covering the glottis would be the epiglottis. The vocal cords are found in the larynx. Mucus-producing cells called goblet cells are found in the lining of the trachea. The interior of the trachea is lined with epithelial tissue called ciliated pseudo-stratified columna. The trachea splits into the left-right bronchi, the main bronchi or the primary bronchi. Gas exchange between air and oxygen takes place at the LVO line. Surfactant is an oily substance produced by septal cells to reduce surface tension in the LVO line. The lungs are surrounded by a double layer membrane called the pleurae. The outer layer is called the parietal pleura, singular, but the E is plural. And then the inner layer is called the visceral pleura. Compliance is the expandability of the lungs. The respiratory center is located in the medulla oblongata, part of the brainstem. We'll learn that in more details next unit. Carotid body are O2 sensitive chemoreceptors located in the carotid arteries and aorta. The total volume of air that can be voluntarily moved into and out of the lungs is called tidal volume. Oh, sorry. It's called the vital capacity. Total volume, right? Emphysema is a condition characterized by loss of elasticity of the lungs because the alveoli are damaged and they're all merged together. Pneumothorax is a condition where the lung collapses due to puncture. Okay, so like a stab wound. Sometimes it can happen spontaneously. Okay, you just wake up and then the lung collapse because of puncture. Happened to a friend of mine. That's that. Okay, long answer questions. Are there any requests? Give you a moment to read through them. If you have requests, please type it in the chat box and I'll go through them. Okay, number 3. Anyone else? Oh, I don't know why it becomes 9, 10, 11. So weird. I probably should fix that next time. Okay, now number 3, explain how surface tension and surfactant in the alveoli affect inhalation and exhalation. We already talked about it up here though, like in this chart, when I try to explain it. Is there like a specific part of this you want me to elaborate, Abdullah? Okay, so again, right, generally the surface tension is basically caused by the moisture inside the alveoli. Okay, so that the surface tension will cause the alveoli to collapse. Okay, because of the attraction between the water molecules. So a lot of surface tension will collapse the lungs. We collapse the not the lungs, the alveoli. Okay, so by collapsing the alveoli, it helps squeeze the air out. That's why it helps with breathing out. But then, if you only have surface tension, then that will make it difficult to breathe in because it always wants to squeeze. It always wants to close, right? So 2 conditions that we talked about, right? In the lecture, there is something called the respiratory distress syndrome. That's when babies are born prematurely, right? And they haven't been able to produce the surfactant just yet. So they will be a little bit bluish because they can't really breathe on their own. Okay, so that's why you have to inject the steroids into their nose as soon as they come out, and that goes into the lung, and that steroid helps break the surface tension and opens up their alveoli. Okay, another example is what we just talked about in the poll question, right? Dawn, right, was not able to produce a surfactant on their own, and so it's going to make it more difficult to breathe in. Okay, so naturally you have the surfactant, which would break the surface tension. By breaking the surface tension, you reduce the recoiling force. You enable the lungs to open more. In fact, the more surfactant you have, the easier it will be to open up your lungs. So it's going to help with inhalation, okay? Because the compliance is now bigger, right? Yeah, it's more compliant. So it will help with breathing in, but then it's not as squeezy now. It's not as elastic now. So it will have more difficulty breathing out. So it's about having the right balance between the surface tension and the surfactant. Does that answer your question, or do you have more follow-up questions? Okay, great. The other ones are pretty self-explanatory. I either already talked about it in the lecture, or it's just straight, from the lecture notes. So if you have questions, feel free to email me. Let's take a look at these application questions. They are quite lengthy. First one, Melisandre learns from the internet that by deliberately hyperventilating, so like inhale and exhaling rapidly, she was able to extend the time she is able to hold her breath. She wants to impress her friend with this, so she hyperventilates for several minutes before diving into a swimming pool, thinking she'll be able to swim further by holding her breath longer. Shortly after she enters the water and begins swimming, she blacks out and almost drowns. I explained why she was able to hold her breath for longer on the land from hyperventilating, but causes her to black out underwater. I believe I briefly explained this concept in the lecture already, but here we go again. So this is a graph that shows, for example, your carbon dioxide level in the blood, in blood carbon dioxide level, we'll say. And then this is time. Okay. So everybody has a threshold, right? This is threshold. If you exceed the threshold, if there is too much carbon dioxide level in your blood, then the medulla oblongata is going to kick in and you will have to breathe. So when we inhale, exhale, right, and then you decided to hold your breath, right, then you have some baseline carbon dioxide level here. If you hold your breath, you are not breathing out those carbon dioxide. And it will continue to climb because of cellular respiration, right? In cellular respiration, you will produce carbon dioxide. So all that carbon dioxide will continue to build up in your bloodstream, okay? And you're holding your breath, and then you hit the threshold, and you will have no choice but to breathe in, okay? So this is how long you can hold your breath for normally. And you can try this. Now, if you hyperventilate, like that, then you are breathing out more carbon dioxide than you normally would. Okay? And if you hold your breath at the end of hyperventilating, your starting carbon dioxide level will be lower than before. So it will take longer to reach the threshold. So this is your new breath holding time, right? It will be longer than before. Okay. The problem is if you do it on land and then you hit the threshold, then you just breathe, right? Like once you can't hold it anymore, you just breathe. Okay. But if you're underwater, a couple problem here with a person here, with the Melisandra. Okay. The problem is she's swimming underwater. Okay. This technique does not increase the amount of oxygen in your system. It just tricks your brain into not breathing by artificially like lowering the carbon dioxide level. Okay. And when you're swimming, you are actually, your body demands more oxygen supply. So not only are you not getting rid of the carbon dioxide, you are also using up oxygen at a more rapid rate. So what happens is your brain is all of a sudden not receiving enough oxygen because the oxygen is being diverted to all your muscles as you're swimming underwater, right? So what happens is you will pass out, right? When you don't have enough oxygen going up to your brain, you pass out. And the first thing you do when you pass out is you lose voluntary control of your body, okay? So holding your breath is a voluntary control, okay? So your central nervous system will override that manual breath holding, and then you start breathing. But of course, when you're underwater and you breathe, right, you breathe in water, right? That's why it's possible to drown like that. But there are these like deep sea divers. Have you guys seen like videos of these free divers, right? Like they are able to go deep into the ocean for like very, very long time, you know, spear fishing and stuff like that, and then come back out, right? They actually build the world's largest diving swimming pool. You can Google that, okay? And it's for these free divers to basically go very, very deep, right, for very, very long time. We're talking about more than 5 minutes in some cases before coming up. And, you know, they have certainly trained their body to do something extraordinary. The physiology, right, the lungs, respiratory system all change to allow them to do that. But if we're just like normal person without training and we try to do this, we're very likely to drown. So don't do this at home. Next, we have Jimmy, who is very stubborn toddler and has just threatened that he will hold his breath until his mom gives him some candies. His mom refuses to be manipulated and watches in amusement as Jimmy stubbornly refuses to breathe. To her horror, Jimmy loses consciousness and collapses onto the floor. Her sister, who is a nurse student, is visiting and tells her there is no need to call for an ambulance. Why did Jimmy, sorry, I'm mixing up the name now, lose consciousness? Should his mother trust her instinct and call for help and begin CPR, or should she listen to her well-meaning but young and inexperienced sister? Okay, what do you think? Call ambulance or don't call ambulance? Is Jimmy or Timmy gonna be okay? What do you guys think? Don't call. Stephanie said don't call. Let the kid be. Yeah, he's probably gonna be okay, right? Based on what I just told you. Right? He held his breath, and then the carbon dioxide level exceeded the threshold. But before natural breathing kicks in, not enough oxygen to the brain, he just passes out. But like I said, holding your breath is a voluntary function. As soon as you pass out, all voluntary action ceases and your body reboots itself, and then he will start breathing on his own again. So he probably will come to his senses within a couple of seconds. Okay, it's just how your body, it's like a safeguarding, right, mechanism of the body. So that is it for today. If you have any question, you can stay and ask. Otherwise, I'll see you on Monday. Okay, Monday we're gonna do the review, and make sure you have your labs, either in an electronic format or you print it out. Okay, before you come to Monday's tutorial. Okay, have a good week and see you all on Monday. Bye for now.